5. Evaluate 0.0741 divided by 23.82. Approximation 0.07 divided by 20 is equal to 0.0035. Solution. The standard form of 0.741 is 4.41 times 10 raised to the power minus 2. Then we look for the logarithm of 7.41, which is 0.8698. Then the bar 2 is from the 10 raised to the power minus 2. Since it's 10 raised to the power minus 2, it will become bar 2. Therefore, the standard form for 23.82 is equal to 2.3 times 10 raised to the power 1. Therefore, looking for the logarithm of 23.82, we have 0.3770. Then since it is in the standard form is 10 raised to the power 1, therefore we have 1.3770. We subtract, since we are dividing, we subtract 2.8698 from 1.3770, which we now have 8 minus 0 will give us 8. 9 minus 7 will give us 2. 6 minus 7 will not hold. We borrow 1 from 8 and give it to 6. After adding 16 plus minus 7 will give us 9. Then we'll be left, 7 will be, 8 will be left, we have remaining 7. Then 7 minus 3 is 4. But 2 minus 1 is bar 3. So this bar will now go over. If you find the anti-log of 0.4928, we have 3.111 times since the bar is bar 3. Since we are having bar 3, therefore the standard form is 10 raised to the power minus 3. So therefore 0.074 over 23.82 is equals to 3.11 times 10 raised to the power minus 3, which is equals to 0.001311 to 3 significant figure. With practice, it will not be necessary to write each number first in standard form. We shall be able to proceed straight to the logarithm. Powers or exponents. To square a number, double the logarithm. This gives logarithm of the square. To cube a number, triple the logarithm. This gives the logarithm of the cube. To a number to any power n, multiply the logarithm by n. This gives the logarithm of nth power. Example 6. Evaluate in bracket 0.621 raised to the power 3. Approximation is 0.6 raised to the power 3, which is equal to 0.216. Solution. The number is 0.621. If you convert it to our standard form, we have 62.1. Then if you get the 62, if you look for the 62, we have at column 1, we have 0.7931. Since it is raised to the power minus 1, 10 raised to the power minus 1, then we now have bar 1. So we now have to times it. Since the root is by multiplication, we times bar 1.7931 by 3 to get bar 1.3793. You will notice that the bar 1 is not times because it is the standard of that number. So we are multiplying 0.7931 by 3 to get 0.3793. Therefore, the antilog of 0.3793 is 2.395. Since the bar is still in the standard form of minus 1, we will now put the minus 1, which is 10 raised to the power minus 1. Therefore, the log of 0.621 raised to the power 3 is equals to 2.395 times 10 raised to the power minus 1, which is equals to 0.240 of 4 or to the raised to 3 significant figure. Example 7. Evaluate in bracket 0.0275 raised to the power 2. Approximation 0.03 raised to the power 2 is equals to 0.0009. Solution. The standard form of 0.0275 is 27.5 times 10 raised to the power minus 2. Therefore, the log of 27 at column 5 in the log table is 0.4393. Since it is in the standard form of minus 2, we have about 2.4393. Therefore, if you times 2, since it is raised to power, the question there is we are asked to get 0.0275 raised to power 2. Therefore, we times it by 2 to get 2 times 2.2 bar 4393, which will give us 4.8786. Therefore, the antilog of 0.8786 is 7.561 times 10 raised to power minus 4, because the 4 will now become the standard form. Therefore, in bracket 0.0275 raised to power 2 is equals to 7.561 times 10 raised to power minus 4. Therefore, to the 3 significant figure, it will become 0.00756. Roots. To find the square root of a number, divide the logarithm by 2. This gives the logarithm of the square root. To find the cube root of a number, divide the logarithm by 3. This gives the logarithm of the cube root. To find the nth root of a number, divide the logarithm by n. This gives the logarithm of the nth root. When finding a root of a number less than 1, we have to perform a division in which dividing the dividend has a negative characteristic. This method needs careful study. Increase the number under the bar to next integer exactly divisible by the divisor. Balance by adding the appropriate whole number to the decimal part. Example.